Morning, everyone. Well done, you've made it to Friday. A great week of maths has been done. Now, for today's lesson, I'm going to do a slightly different warm-up because what I would like to do is try and teach you how to multiply by decimals in a slightly quicker way to help you be able to do some of them in your head. You've all got a really great understanding now of how to adjust multiplications with decimals using your known facts. And here I'm going to teach you a little trick that's going to help you speed up even more. Now, these 6 questions I'm going to talk you through. Now, what I want you to do is you're going to keep remembering inside about your known facts. We still need those known facts. This is a little trick which works for multiplying your decimals. Now, let's look at the first one. 0.1 times 8. Now, our mind will be thinking, right, known fact, 1 times 8 is 8. Hopefully we're all thinking, well, 0.1 is 10 times smaller, so my answer is going to be 0.8, which is correct. Now I want you to look at this, that when you're multiplying by a decimal, if it has one digit, like it does here, the 1 after the decimal point, that means your answer also has to have 1 digit after the decimal point. So let's have a look at it for this one. 7 times 0.05. Now this time we've got 2 digits after our decimal point. So that means our answer this time is going to have 2 digits after the decimal point. Now we're thinking 7 and 5. 7 times 5, our known fact is 35. But we know that our answer has to have 2 digits after the decimal point, so our answer must be 0.35. So the starting decimal that you are using is a real key for you to know, is my answer correct? Now this only works for multiplying a decimal by a whole number. If it's 2 decimals, we're going to look at that another day. It still works, but you have to consider both of them. But for today, just think about it with a decimal and a whole number. So 0.7 times 8. Now, 7 times 8 is 56, but I've got 1 digit after the decimal point, so my final answer must be 5.6. It doesn't matter about the digit before the decimal point, it's this one that is given to you by how many digits are after the decimal point in the starting point of your question. So 7 times 0.9. 0.9 has 1 digit after the decimal point. 9 times 7 is 63. So I've got to adjust it and it's going to become 6.3 and then it fits. And so on. 0.06 times 3. My known fact is 18. There's 2 digits after the decimal point this time. So it's going to be 0.18. And for the final one, my answer will be 0.05. Hope that makes sense. It's a really good way of being a bit more speedy through these types of questions. So here is a table with 12 questions. So I'd like you to pause the video and see if you can use the method I've just taught you. If it's a bit confusing and you want to use your own facts and then adjust, that's absolutely fine. But for those of you that are really happy with that, this is a good next step to help speed you on. So pause the video and have a go at this and come back when you're ready for the answers. Okay, so well done. Hope that's helped a little bit. I'm going to pop the answers up for you here. So you can have a little bit of time, maybe pause the video to scan through. I'm not going to read them all out. It doesn't seem that that's a good use of our time, but pause it, check which ones you've got right and wrong. If there's anything else about that that you're not sure about or you'd like some more practice, do send me a message through Dojo and I can sort out some questions for you to have a go at some more. All right, for today, our WALT for today, we're going to be learning how to divide decimals. So the opposite of the last couple of days. And our will, what we're going to be able to do is use the term decimal fraction for a decimal number. We're going to use our multiplication facts to help us divide and hopefully use some diagrams to help us divide as well. Now for our Discover, here we are in, looks like the science lab. And on these weighing scales, you can see that they are equal in weight on both sides. Now one side, over this side here, we're being told it weighs 0.8 kilograms. Now the question is saying if four small blocks balance a 0.8 kilogram box, what is the mass of each of the purple boxes? So we know the total has got to be 0.8 because it's equal, it's equalized, it's balanced with the blocks on the other side that we know the weight of. So how are we going to work out the weight of one box? First of all, what's our calculation going to be? Well, we've got to decide 0.8 divided by 4 equals what? And that's going to tell us how much one box would weigh. So there it is in a diagram. So we know that the total mass of the 4 blocks is 0.8 kilograms. So we've got to find out 0.8 divided by 4. Now, this boy here said he thinks he can use multiplication facts to help him. So 0.8 divided by 4 equals what? Or he's looked at the inverse thinking, well, what do I got to times by 4 to give me 0.8? Now over here I think is the most important bit, our known fact. We know that 4 times 2 equals 8, and we know that 8 divided by 4 equals 2. Now, similarly to how we handled our multiplication, you can see underneath here that we can adjust. So if we know that 8 divided by 4 is 2, 0.8 divided by 4 must be 0.2, because the 0.8 is 10 times smaller than 8. Therefore, our answer needs to be 10 times smaller than 2. I quite like this bar model because it shows the total amount of 0.8, and you can think, well, if this is correct, and I put 0.2 in each of the 4 boxes because we've divided by 4, and I add them together or multiply them by 4, I'm going to get the same answer of 0.8. So bar models, I think, can really help you to visualize what's going on and does it make sense what you have put as an answer. Now, we're going to take the problem a step further now. So imagine now someone got an 8 kilogram box and put it on the scales. Okay, now to start with, we had a 0.8 kilogram box. Now we've got 8 whole kilograms. And the question says, how many purple blocks will make the 8 kilogram box balance? So let's think about what we know. We know that for 0.8 of a kilogram, we needed 4 blocks. That's what we just did on the previous slide. Now, 8 kilograms is 10 times heavy as 0.8 kilograms that's on the scale now. So that means 10 times as many blocks will balance the scale. So to find out how many purple blocks we need for 8 kilograms, we're going to use our answer from the previous question, knowing that 4 blocks are needed, 0.8 kilograms, which is what we found out over here. And then if we multiply that by 10, we find out that 40 blocks will balance 8 kilograms, because 8 kilograms is 10 times larger than 0.8. So some of these calculations you need to just think of in small steps, work one part out and see how you can use it to help with the next step. All right, now then, for our think together. Or let me move me out of the way because I'm in the middle of the question. Over here, look, there we go. So we've got now a bottle containing 1.2 litres of juice. Now this juice is shared equally between 3 glasses. So how many litres of juice are in each glass? So our question that we're trying to answer, first of all, is 1.2 divided by 3, isn't it? Because what we want to know is how much does each glass get of that 1.2 litres? So we're thinking I've got a total of 1.2 and I've got to share it between 3 glasses. Now my known fact is going to be 12 divided by 3, which is 4. But we want to know 1.2 divided by 3. So my answer has got to get 10 times smaller because 1.2 is 10 times smaller than 12. So all I've done is I've divided my 4 by 10. Okay, so each glass will get 0.4 litres of juice. Now, how could I check that that answer is correct? What could I do? I could think about the inverse, couldn't I? Now, the inverse means the opposite. So the inverse of division is actually multiplication. So if I took my 0.4 litres and times it by 3, I should get an answer of 1.2 if I'm right. And it does. 3 times 0.4 would give me 1.2, so I know my answer is correct. All right, now, for today, you're going to be working on pages 27 to 29 on dividing decimals. Now, I've done another slide today because before you go into your books, I just wanted to give you a top tip for question number 3. I think everybody should be okay with questions 1 and 2 if you read them carefully. Now, question 3, I think, could seem a little confusing because the numbers that you're dividing by might throw you a little bit. It might not, you might be fine. If you want to just get started, that's great. Or if you want to answer questions 1 and 2, pause the video and then come back, that's also a good idea. Now, question 3 is asking you what 0.2 divided by 4 is. Now, when we've been using our known facts, we have been thinking, it's been sort of quite obvious how it's working. Now, in this case, our nearest known fact, I think that we know, is that 20 divided by 4 is 5. Now, this time, 0.2 is actually 100 times smaller, isn't it, than 20? Because 10 times smaller than 20 would be 2. And 100 times smaller is now 0.2. Now, this makes, I think, sometimes it difficult to spot and sometimes a bit harder to think, well, what is the known fact that I need? So sometimes with your decimal, you might need to multiply by 100 rather than just 10 to try and grasp your known fact to start with. So if I know that 20 divided by 4 is 5, and I know now that 0.2 is 100 times smaller than 20, that means I've got to then divide 5 by 100 to give me an answer of 0.05. So this is the answer to the first part of question 3, but I wanted you to have this in front of you if you are getting a bit stuck, and then you can use it to help you answer B, C and D. So just remember that when you're spotting known facts, that sometimes they might be 10 times, 100 times bigger, or to use the inverse, because I could have also thought, well, 4 times 5 is 20. That would be the start, but sometimes that's a bit more tricky to then apply and put into division. So I'm going to just whiz back here. So your work is on pages 27 to 29. And as always, the challenge is here for if you are wanting to come back and do a little extra. So good luck. I also want to make it clear that if you are finding this quite challenging and you only get questions 1, 2, and maybe some of 3 done, that is okay. All right, just send me a little message because that's no worries at all. Especially if you're in my group, questions 4 and 5 are another level harder. And so if that's one step too far, don't worry, just do what you can. Obviously, if you're finding it a doddle, keep going and do as much as possible. I don't want you to get yourselves in a twist that you can't finish everything. So good luck, and I will look forward to seeing your work. Have a lovely weekend, and I'll see you again on Monday. Take care. Bye-bye.